All right, so this is this is chapter 1 for Workplace and Apprenticeship 20, and I'm just going to go through parts of the workbook here. We're going to talk about some definitions, look at some examples, and work through some things together. So chapter 1 is called Slope and Rate of Change. Okay, now look at this guy right here. There's a skier, and obviously it looks like he's maybe come off this ramp right here, and he's maybe doing a spin in the air. That's what it looks like to me. It looks like he's going this way. What do you guys think? Do you guys think he's going this way? Or do you guys think he's maybe coming back this way? I don't know. Which way do you think he's going? Or do you maybe think he's going straight down? I don't know what's happening here. Maybe he fell from a plane or something. I don't know. Does this make sense? Do you guys agree with me that this comes off the ramp here? Okay. I was just watching the X Games here the other day, just some clips here. And our Regina boy, Mark McMorris, he won gold again. It's awesome. But anyways, they come off these ramps and they do all these flips and turns and stuff. And this ramp right here represents a slope, right? Have you guys ever been skiing? Anybody been skiing before? You have? Nathan, have you been skiing? Never been skiing? Okay, sometimes when you go skiing, you say, let's hit the slopes. You ever hear that? We're going to go hit the slopes. Well, the slopes are the hills, right? The mountains, or the hills here in Saskatchewan, if you're going skiing here. But the slope means like an incline if you're looking up, or a decline if you're looking down. It's not flat, right? It's something else. So that's what we're studying here. We're studying slopes. Okay, so there's a couple definitions we want to talk about here as we look into 1.1. And the first one, and you'll notice the highlighted terms in your workbook there are the important words that we need to know what they mean. So a ratio is a comparison between two numbers measured in the same units. For example, if an engine runs on a mixture of gas and oil and needs 15 liters of gas for every 1 liter of oil, the ratio of gas to oil is 15 to 1. Okay? 15 to 1. All right? If we have 30 liters of gas, we need 2 liters of oil because it has to be the same ratio. So another way to write that is 15 to 1 or 15 over 1 here. Okay? So a ratio. Now you have a copy of, you have this workbook in front of you, so you can highlight or underline or whatever it is that you normally do. You don't have to rewrite it out here because I got it right here, but I see some of you are marking up, circling things, or whatever you need to do. You go ahead and you can mark up that workbook, okay? All right, a proportion. Okay, what is a proportion? Well, a proportion is a statement of equality between two ratios. Okay? It's a statement of equality between two ratios. Right here. I've got it summarized right here. If an engine twice the size of the one above needs the same gas mixture, which I actually just did mention, so 30 liters of fuel, we would need 2 liters of oil. Okay? So a mixture of 15 to 1 is the same as 30 to 2. We double the one, you have to double the other one. And so this is a simple proportion right here. See, it has an equal sign, and it's got two ratios. Okay? That's what a proportion is. Any questions there so far on these two? Pretty straightforward so far? Okay. All right. Let's take a look at example 1, which calls, it's a recipe for vegetarian chili. All right. And the recipe says this. This is what we need, guys. 15 ounces chopped tomatoes. Sorry, 15? Did I say 15? 56 ounces chopped tomatoes. 30 ounces of kidney beans. 15 of whole kernel corn. Okay? So what is the ratio between corn and kidney beans? Or corn to kidney beans? Well, here's the corn number. And here's the kidney bean number. Okay? So the solution is 15 to 30. And there it's written right like that. Okay, does everyone see that? The number that's attached with corn to the number that's attached with kidney beans. Now the special thing about this ratio is that it can be simplified, right? Just like you remember simplifying fractions maybe in math before this. We could simplify 15 to 30 because 15 and 30 both can be divided by the same number. We can reduce them by the same factor, and that factor is of course 15, right? You can divide both of these numbers by 15 to get a simplified ratio of 1 to 2. Right? 15 to 30 is the same as 1 to 2. All right. Okay, what's another ratio that's equal to 1 to 2? So 15 to 30 is one that's equal to 1 to 2. Can you think of another ratio that's equal to 1 to 2? Anybody? What's another ratio that's the same as 1 to 2, but we use different numbers? 2 to 4. Yeah, 2 to 4 is a good one. Okay? 2 to 4, right? The first number, you double it to get the second number, right? 1 to 2, 2 to 4. Okay? There's another one. What's another one? 5 to 10. Yeah, does that make sense? Okay? Do you have one? Can you think of one? 3 to 6 is perfect. Yes. Exactly. Okay? 3 to 6. All right. Very good. So, okay. So, let's see. Oh, B. I guess we didn't do B, right? Well, B is this. I mean, it's very similar, okay? So, tomatoes to kidney beans. That would be tomatoes to kidney beans. 56 to 30. 56 to 30. Okay? 56 to 30. Now, what is this reduced? Could you reduce this? Well, all you have to do is you have to find a number that divides evenly into both of those. And so if you want to reduce a ratio, that's all you do. You can get on your calculator. So let's just quit all this and clear this. And I've got 56 and 30. And you could say, all right, is there a number where I could divide both of them by the same number and get a round answer there, a whole number answer? So I would try this, like 15, let's say, I'm going to divide that by 3. Does that work? No. So 56 is not divisible by 3 because that's a decimal. Does everyone see that? Would 56 be divisible by 4? Let's see. Ooh, it's divisible by 4. You see that? Now let's check 30. Is 30 divisible by 4? And, oh, there's a decimal. So you can't divide both by 4. So that's why they chose 2. 2 is a number that works to get to 28 to 15. Okay? That's simplifying a ratio. All right. So let's do some examples together. Let's do some examples together from scratch. So you have this in your notebook, and I'm going to clip this into our notes here. Be able to work on this together. Okay. So you have a pencil or a pen or something handy, right? Hopefully you do. Okay. So in a juice mixture, okay, so here's our first question. In a juice mixture, 750 milliliters of water. Oh, my computer's freezing up on me, guys, sorry. $750 milliliters of water are mixed with 250 milliliters of juice concentrate. So if you're making juice for the family picnic, okay, you might see on the can of juice or on the big container of juice that you need 750 milliliters of water for every 250 milliliters of juice concentrate. That would be the mixture. What is the ratio of concentrate to water? So what we do is we look at which number is associated with the concentrate. Well, it looks like 250 is, right? So we're going to write that one down first, 250. And I'm going to use the colons here, this little dot dot, right? I'm going to use that. And then to water, it's got to be the next one. So the water is 750. So we're going to do this. Okay? So concentrate to water, 250 to 750. There's your answer. Okay? Just use the numbers that are associated with it. Easy, right? Okay? Now, could we simplify this ratio? Is there a way that we could make these numbers smaller and keep the same ratio? So you want to see if you could divide each of these numbers by the same number and still have whole numbers when you're done. So is there a number that you can divide them by? Well, I'll show you a little hint here. If both of them end with a 0, you can always divide by 10, guys. Because you can always divide by 10. So 250 divided by 10 is 25. And 750 divided by 10 is 75. Okay. Now, that's another way to reduce that ratio. Could we go any further? And I will encourage you to think about this, okay? Now, I don't know if you know what I'm drawing here. I'm not a very good artist. But I am drawing something. And over here, I'm going to cheat here for a second. Just watch this. Watch this. I'm going to copy this. I'm going to paste it. I'm going to paste it again. I'm going to paste it again. Look at that. Totally cheating. What do you think these things are that I drew? Quarters. Quarters, right? If you think about money, this is a 25 cents, 75 cents. So check this out. What's my simplest ratio here for these numbers? 25 to 75 simplifies to what? What's the hint? What is it? Yeah? Is that right? 5? Yes, you could divide them by 5. Yes. But, watch this. If 25 cents represents 1 quarter and 75 cents represents 3 quarters, do you guys see that the simplest ratio here is actually 1 to 3? See that? Okay. So you're right. You could divide both of them by 5 and get it smaller. But you could keep doing that, dividing by different numbers, and this would be the smallest ratio ever. 1 to 3. Okay? So all of these would be okay. 1 to 3 would be what's called the simplest ratio. Okay? The simplest ratio right here. Okay, let's do another one. Let's do another one. Let's go back to our workbook here. Okay, so I am going to do number 2 as well with you, and then I'm going to get you to do number 3 in your own. Okay? So, let's paste this one in and see where we go from here. Okay, to mix a certain shade of green paint, a painter mixes 2.3 liters of blue. Oh, I should use a blue pen here. 2.3 liters of blue paint, and oh, do I have yellow? I do. And 1.7 liters of, oh boy, I can't see where this yellow is though. Yellow paint. Okay, to make a certain shade of green. What is the ratio of blue paint to yellow paint? So the ratio of blue to yellow. Well, you look at the numbers. They have the same units, both in liters, and those are the numbers that we're going to compare. So the ratio, let's put it in another way. Let's put number, so this is blue, and let's put it over top of the other one. So let's put the yellow on the bottom. What's the number that's associated with yellow? 1.7. Okay? Oh, actually, look at that. I didn't even read the rest of the question. Express your answer as a fraction. Okay, well, this is a fraction, right? This is a fraction. Okay, now, could we simplify it? Maybe. If you think about the number 23 and the number 17, those are prime numbers. That means that there's no other number other than 1 that divides into them. So this is going to be, this is great. This is your final answer. Okay? Blue paint to yellow paint. All right. So I'm going to get you to, right now, I'm going to get you to do that third question that's in your workbook. I'm going to get you to do this one on your own. See if you can do it. And if you get really stuck, you can ask me or you can ask a neighbor. No problem. But why don't you go ahead and try number 3 there. Okay? Okay, hopefully you've all had a chance to try all 3 of these. Let's go over this real quick. Okay, so 3A, the ratio of oats to raisins. Well, let's see. The oats right here is 6 cups. Raisins is 1. Frozen? All right, thanks. So the ratio should be 6 to 1. Did anybody get that? Okay, good. 6 to 1. Now, is this simplified? If one of them is 1, it's simplified. That's as simplified as you can get. You bet. Okay. Unless we have a decimal or a fraction over here, 1 is good. If you have two whole numbers like that, it's perfect. So we're going to talk about that in a bit here. Okay, what's the ratio of almonds to coconuts? I had a question about this. Okay, 2 cups almonds, and coconuts is, look at this, 3/4 of a cup. So if you have a recipe, a lot of times it's a quarter of a cup, or 3/4 of a cup, or a third of a cup, or half a cup. So sometimes it's fractions, right? So almonds would be 2, and coconuts would be 3/4. Okay, so that's the ratio between those two. Now, if I wanted to get it to a ratio where we don't have any fractions, but we just have whole numbers, okay, do you guys know what I would do if I wanted to get rid of this 4 as a denominator there? Who remembers what the math thing is to get rid of a denominator? Do you remember what you do if you want to get rid of a denominator? What's the opposite of dividing? Multiplying. So, remember how before we had big numbers and we divided them down to get to those smallest numbers? Well, if you have a fraction, what you're going to have to do is you're going to have to multiply it to make it bigger to make some whole numbers. So that's what we're going to do. So to simplify this, we're going to multiply each by whatever number is in the bottom there. And we're going to multiply both sides. So this is going to turn into 4 times 2 is 8. And when we multiply 3 over 4 times 4, look at this. The 4 cancels out with the other 4. So that's just 3 right there. So that's how you get rid of a fraction. That's how you make the smallest whole number ratio. So this is the smallest whole number ratio. Okay, guys? And that's something that we're going to be very interested in, is whole number ratios. And of course, we're going to be interested in the smallest one, so this is good practice for us. All right, so C is very similar, except there's an added twist to C, all right. This is tricky. This is tricky. It says the ratio of oats to the total ingredients in the recipe. So the total ingredients would be adding up all of the amounts. Okay? So we have oats to the total. So let's find out what the oats are, first of all. The oats is 6 cups, right? So we're going to put 6 there, no problem. Well, what's the total? Oh, the total is going to be 6 plus 2 plus 1 plus 3/4. Okay? So 6 plus 2 plus 1 is 9. And then we have 3/4. All right? So that is the ratio of oats to total ingredients, 6 to 9 3/4. So that would be your first step. Now, if I'm looking for smallest whole number ratios here, I'm going to want to get rid of the fraction. Okay. So this is called a mixed number. Do you guys remember that? Mixed number? Do you guys remember how to make this into an improper fraction? Close, close. You multiply the 4 times the 9, that's right. And then you add 3, and you put it over 4. So that's a good guess. You were super close. So let's change that. So 4 times 9, that's going to be 36, right? What's 36 plus 3? 39. So it's going to be 39 over what? 4. Okay? So that's your first step. Let's write it as an improper fraction. And then we're at the same spot that we were in. We're at the exact same spot we were in. Oh, is this mine?
No, that was in the last one.
Oh, wait. Okay, sorry about that. So we have now we have a fraction, right? So what do we do to get rid of the denominator, this bottom part of the fraction? We multiply both by, we're going to multiply both by 4. Right on. So then the smallest whole number ratio is actually going to be 4 times 6 is 24. And then the 4 would cancel out with this 4. And we're going to have 39. Okay, so that's a whole number ratio, but it's not the smallest. Because if you get your calculator out and you start dividing these numbers, so 24 divided by, well, let's say 3, that gives us 8, and 39 divided by 3 gives us 13. So the actual smallest whole number ratio is 8 to 13, because we can divide both by 3. Okay? So that's a little bit of work there, all right? But that would be our final, simplest whole number ratio answer. Questions? You guys think you can do that kind of stuff now? Yeah? Okay, so here's the second and last example for this little section here. This one talks about a big screen TV. So have you guys ever heard of an aspect ratio before? An aspect ratio is sort of the shape of the TV screen. Okay? Most TVs nowadays have an aspect ratio of 16 to 9, which means that you would have the top part would be 16, whereas the side would be 9. So it would be a ratio of 16 units to 9 units. Now, bigger TVs would be much bigger than 16, let's say, inches, right? They would be maybe 32 inches, right? Or maybe 64 inches. Well, we could find out how tall they are because of the math that we're learning here. So let's see what this one says. A big screen TV has an aspect ratio of 16 to 9, which means that for every 16 inches of width, the TV is 9 inches high, what we just explained. So what's the height of the TV that is 40 inches wide? Okay, so here we've got a width and a height. That's the 16 by 9. And we've got another width, the 40, and we're asking for the height. So this is where the idea of the proportion comes in. So look at this. See, this right here is a proportion. Remember we learned about what a proportion was? And I can't really highlight that one very well. That's a proportion. So 16 over 9, or 16 divided by 9, or 16 to 9, equals 40 to what? And you can set up an unknown value here in this math proportion. So that's what they did. They set up this proportion, and they solved for x. Okay? So now I'm going to show you, this is maybe a little confusing here, so I'm going to show you just another way that you can do that. I feel like I bumped something. I did. Why do I keep bumping? Okay, there we go, back to normal. Okay, so let's take a look at this here. How do you solve for x here? Well, you want to get x all by itself, but right now it's in a ratio and it's in the denominator. So what we want to do is we want to get rid of the denominators. Remember, we want to get rid of them. We want to make them whole numbers or get rid of the fractions altogether. So I have a 9 in the denominator and an x. So watch what we're going to do. We're going to multiply everything, that's both sides, by 9x, guys, okay? By 9x, because we want to get rid of both of them. So 9 times x, that's what we're going to multiply by. Put that there. And so what's going to happen? Well, the x up here is going to divide out with the x down there. So I'm going to be left with 9 times 40. What's 9 times 40? You might have to get your calculator out for that one. 9 times 40, what's that? 360, very good. So do you see how the x's are gone here? So I just have 9 times 40, see that? Now I have 16 over 9 times 9x. Well, look at this. The 9's now cancel out. And I'm left with 16 times x, which is 16x. Okay? That's step 1. To get x all by itself now, I have to get rid of the 16 here. So I'm going to divide, because it's multiplied, I'm going to divide it off, and you do that to both sides. Okay? So if you guys show your work like this, it won't be so daunting, like it won't be so difficult looking. I would strongly encourage you to do that. And so then the 16s are going to cancel out, and you're going to be left with x equals, what's 36 divided by 16? We do that on our calculator, and we get 2.25. Sorry? Oh yeah, 360, so 22.5. Thank you, I missed a 0 there. 22.5. Okay, so if we go back to the work here, look at, they got the same number, and really they did the same thing. See, 9 times x times that, 9 times x times that. That's what they did. Divided by 16 to get this number. So what this number means, remember we solved for the unknown value, which is the x here, which means that's how actually tall this TV is. See that? If it's 40 inches wide, if it's got the same ratio as 16 to 9, it's actually 22.5 inches. Whoa. The height. That should be high. That's a typo, I think. That should be high. That's wrong. Okay? It's 40 inches wide. That means it's 22.5 inches high. Okay. So I am going to let you guys attempt all of these. This is your kind of homework for the day, okay? See if you can do all 3 of these questions, and I will show you the answers here in a little bit, okay, towards the end of class. Go ahead and take a chance on those. Okay, so another way to look at this, you could multiply both sides by 4x, or something you may remember from grades past is cross multiplying and then dividing. That's really the same thing that we just did. This is a bit of a shortcut, cross multiplying and dividing. So that becomes 15x. You see that? X times 15. And this becomes 4 times 20, or 80. So that's another way to get to that step, cross multiplying. And then of course the other half of that is dividing by 15. That's the number that we have to get rid of here on the x. So then up here, then x equals, what's 80 divided by 15? 15 equals 5.3 repeating, or let's just do 5.3. And that would be the amount of oil that you would need. And it's of course in liters of oil. Okay? Okay, so for the next one, right, to get you guys started on the next one here, we've got 10 centimeters on a map represents 25 kilometers of actual ground. How many centimeters would 45 kilometers of actual ground be on the map? Okay, well, a ratio really should be made in the same units. However, when we're doing a proportion, as long as the units on the top and the bottom match up with each other like that, top to top, bottom to bottom, it's actually going to work pretty fine. So let's do this. Let's do 10 centimeters for every 25 kilometers. See that? That's going to be your first one, 10 to 25. And we could make these numbers the same units, but for a proportion like this with an equation, it's actually going to work okay. And then it says how many centimeters. Okay, so where does the x go, top or bottom? Because I'm looking for how many centimeters would be on the map. So should it go on the top or the bottom? Where are the centimeters on the other side here? On the top. So over here we're going to put x centimeters on the top. Okay? So you got to keep your ratios consistent like that. And then 45 is the number now that goes here. Okay? Okay, so go ahead and cross multiply and divide and see what you get there. All right. So if you finish that off, you should get 18 centimeters on the actual map. Okay, so I'll get you started on this last question as well here. So a recipe for corn chowder includes 3 cups of corn, 2 cups of water, and 1.5 cups of cream. If you increase the yield of the recipe and use 4.5 cups of cream, how much corn will you need? Okay, now that sounds pretty confusing, but not if you think about it as a proportion. So we're talking about cream and corn, right? So we don't worry about water actually in this question. We don't even need to worry about it. So the ratio that we know of is 3 to 1.5. So watch this. 3 to 1.5. I'm going to set that up as a ratio. And then over here, that's corn on top, cream on the bottom. And so 4.5 cups of cream goes here on the bottom with the cream. And we don't know how much corn we need. You see that? So if we get rid of these units, now that we have them straight, it's 3 to 1.5 equals x to 4.5. And you can change those to improper fraction. I don't really care. It doesn't really matter to me if you change it to a decimal even, right? So 4.5 could be 4.5, 1.5 could be 1.5. So cross multiply. And yeah, I'll give you a chance to finish that one on your own. Use your calculator, find out what x is. All right, so if you cross multiply and divide there, you should get x equals 9 cups of corn. Does that make sense? Okay, 9 cups of corn. Okay, so that's kind of the first, that'll be the first lesson. We did a couple of those examples and build your skills. So we're going to move on to working with slope. Okay, next day. What I would like you guys to do, okay, I want to see if you can do number 7 on your own. Okay, so we're going to talk about this next day. I want you to read through example 3 and try and do number 7. That's your homework. Okay? Dealing with slope.